here are solutions for quiz 2 for Math 243. What we're given here, we're not even given data, we're given a stem and leaf plot representing the data. So below is a stem and leaf plot showing the height in feet that 20 dogs were able to jump. And this is kind of telling you that 2/1 represents 2.1 feet, okay? So like this dog, for example, jumped 3.3 feet. This was 3.5 feet, and so on. Use your calculator to sketch a histogram of the data with bin lengths of size 1. Okay. What we first have to do is put our data into a calculator. Maybe I'll put mine into L2 here. And then just be careful when you're putting it in. 0-2 represents 0.2. So 0.2 is our first observation, and then 0.7 is our next one. 1.1, 1.5, 1.6 and 1.8. Maybe I'll pause this and put in the rest of the data. Alright, I figured you didn't want to watch me do all that. Now I've got all these observations in here. It's asking me for my 21st observation, which is good because I was supposed to put in 20. So I got all my data in here. And what I want to do is sketch a histogram. So specifically a histogram with bin lengths of 1. So the way you do that is you get your data in. Mine's in L2. And then you go into your stat plot menu. Second and then y equals brings up stat plots. And then press enter to get into the first one. Turn it on. Tell it you want to make a histogram. And then tell it where your data is. My data is in L2. So I'll hit second and then 2 to say L2 here. Frequency is something I will leave alone. And you go down here to window. And you tell it. My smallest observation is 0.2. So maybe I'll start it at 0. My largest observation is 4.0. But my bin lengths are size 1, so my last bin will go all the way up to 5. My bin lengths are size 1, so 1 goes here. And the maximum, the largest bin should be 1, 2, 3, 4, 5, 6, 7. There's 8 observations in the largest bin, so maybe I'll have it go up to 10 just so there's a little border around it. And I can leave everything else alone. So if I hit graph, what will happen is my calculator will spit out a histogram with those criteria. So you might even want to write up here something like calculator stat plot, and just let me know that you know where you're getting your data from. And then whoops, I'll create my histogram. 0, 1, 2, 3, 4, 5. And then it looks like start out with a couple here, then a little bit more in my next bin, and then even more in my bin after that, and then a little bit less, but still more than this guy, so maybe somewhere in here, and then my last one just got 1. So something like this. You can label more if you want. I usually don't. I get kind of lazy on these things. There's 10 way up here. It's a little bit less than 10. Here's 1, 2, 3, 4, 5. So 5 is right here. Good enough. You can figure out the rest of it. Here's a histogram with bin lengths 1. Comment on the shape of the data. I would say this data appears to be bell-shaped. And there's a lot of different ways you can describe that. You can either say bell-shaped, you can say symmetric, you can say approximately normal, maybe I'll even say any of these are okay. So data appears to be one of these things. It doesn't look left or right skewed to me. It's these things. Okay, calculate the mean, the median, and the mode of the data and comment on which is the best. Sure. Mean, x bar, I can get that straight out of my calculator. Median, m, I can get that straight out of my calculator. Mode, my calculator doesn't give me that because it's kind of stupid, but not the calculator, mode. But you can look at this and try to figure out what observation occurs the most frequently. We got 2.0 occurring twice. Got 2.8 occurring twice. I think those are the only two repeats. So it would be bimodal. I don't care if you use that word at 2.0 and 2.8. Make sure I got those right. Yeah. And maybe I'll even put bimodal in parentheses. So the grader knows that those aren't parentheses. Yeah, those are parentheses. So that the grader knows that I don't really care if you write that or not, but that's the technical term for it. Mean and median. Okay, the way we'll do that is we'll come back over to our calculator here, and if you hit the stat button, then go over to the calc menu, we want one variable statistics, but we want it to do one variable statistics on this data, which I put in L2. So I'm going to hit second and then the number 2, and it'll kick out that X bar is 2.38. And that my median, you got to scroll down a little bit, is 2.35. The median and the mean, very similar, something we expect to happen when we're talking about approximately normal, bell-shaped, symmetric data. And I would say that the mean is most appropriate. I don't know if I care if you say why, but the reason why is because the data is not skewed, because the data is symmetric. Or bell-shaped, or approximately normal. All right, I guess the last part, calculate the range, the variance, and the standard deviation. I can do that. The range, maybe I should label these better. Not because you have to, but just in case someone's trying to make sense of this from my solutions. The range, sometimes you'll see capital R used for this, and it's the difference between our largest and our smallest observations. So the maximum minus the minimum. So two things our calculator gives us, or you can just look up at the data. The maximum was 4.0, the minimum was 0.2. If you do 4 minus 0.2, you get 3.8. The variance. Maybe I'll put that on hold for a minute. I'll first do the standard deviation. I guess I asked these in kind of a confusing way, sorry. Standard deviation, use the symbol S, and the calculator gives you that. It's up here. 1 point. Then I don't really care how you round it. I'll probably show 2 decimal places, so 1.05 would be how you'd round that. Then for the variance, it's just that value squared. So you take this 1.05. You could square 1.05 if you want, although to be more precise, we really should put in 1.0536, 1533 squared, and you get that it's 1.11 if we round that off. Yeah, that looks good. So here's my standard deviation, here's my variance, here's my range. I guess that's the end of the quiz.